Hey everyone, welcome to another web series which would be on web security. So I talked about web security a little bit in the last month and discussed with you guys where you suggested that yes, it is a good topic to cover here. So I just decided to create a structured playlist, a structured way so that you can at least get into web security a little bit. That is just giving you a little push. Otherwise, web security is basically a field in which you can explore a lot of stuff and you can always learn. So the motive of this presentation, this web series, is basically just introduce you to web security, what it is, how it works, how you can get into it, and eventually what we would cover as we proceed towards the end of the series is we would cover vulnerabilities in OWASP top 10, which basically list a lot of common vulnerabilities on the web. We would see how we can learn and practice web security. There are a lot of great resources online. In fact, I'm trying to build one on codedamn itself. We would also see some real world exploits and hacks, stuffs, how you can, make use of real world vulnerabilities in the systems. So yeah, that's pretty much it. I am pretty excited to see everyone in this playlist if you have a little bit of interest in web security, and we will cover how you can get into that pretty smoothly. Welcome to the second video in web security, and we'll be taking things slow and basic to advanced. So I just want to start off with a very basic concept, a very basic thing, which I really believe everyone should know, and that is how the HTTP protocol works. Now, HTTP protocol, as we know, or if you don't know about it, it's basically the way websites work on internet. So if you go to example.com, if you go to google.com, if you go to Facebook, Instagram, twitter.com, whenever you end up writing a URL, some website.com in your browser, what you're essentially doing is you're writing HTTP in front of it, or HTTPS, which is just a secured version of HTTP, right? So HTTP it stands for Hypertext Transfer Protocol. And because it is a protocol, it basically means it's a way for machines to communicate. A protocol is a set of instructions which could be used by two or more parties in order to communicate effectively, right? I could say that it could be called as language of the web, not the internet, the web. The web is basically a small part of internet. And it is an application protocol which is on layer 7 on the OSI model. Coming to OSI model, it's basically segregates the network communication into 7 layers, starting off from the physical layer all the way up to application layer. And each layer abstracts away a lot of complexity, a lot of mechanisms, and in a lot of cases provide a lot of stability and abstractions as well. For example, at transport layer, that is layer 4, we have TCP protocol. And TCP protocol is used by a lot of protocols on the application layer as well. HTTP uses TCP, SSH uses TCP, and so on and so forth, right? So moving forward, let's see how the HTTP actually works, right? So HTTP protocol works on the basis of something known as request response model, right? So a request response model means that you have to request something from the remote server in order to get a response. And as I told you, HTTP right here, which is on the application 7, layer 7 application protocol, uses TCP, which is another protocol in the transport layer. A transport layer protocol handles the transport of packets from one computer to another. So TCP is another protocol which is used by HTTP, right? So HTTP is built on top of TCP. Now, why is that? Because TCP provides all that packet transmission and stability, whereas HTTP could focus on what you need to transfer to the other machine, right? So TCP could be the core of the working, and HTTP is the actual implementation of what you need to do, right? So once we have that, we have another protocol called UDP, if you have seen that in the OSI model. Now UDP is another ball game, but we'll discuss it very briefly here. So UDP kind of works on one-way model. I'm not really sure if that's the right way to say it, but if you're using UDP, that means that the origin machine, that is the machine which is transmitting packets, would just keep on firing packets to the end machine and does not really validate whether those packets are being received or not, right? TCP, on the other hand, ensures stability and ensures that all packets reach to that other machine. If they do not reach to the other machine, TCP retransmits them, right? So it ensures that particular thing. All right, coming to request response model, what we have is that time is not as valuable as data, or let me rephrase this. Data actually is much more valuable in request response model. For example, in HTTP protocol, you do not want that your server just sends you half of the page or maybe the full page with a little bits and pieces missing in between, right? We are okay with the fact that server takes, let's say, 200 milliseconds more to respond with a full response rather than 200 milliseconds faster, but with a broken response, right? So request response model means that we value data more than time. And HTTP works with that. So let's see a very simple example of a simple HTTP request response. And I'm going to make use of a tool called Netcat. So Netcat is basically a tool which you can use to communicate with raw TCP and UDP client server. So what we need to do is right here, let me just go back, and you can see I have a PHP kind of server running here, not really running. You'll see that we have this index.php file, and you see it just says me hello world. Right, let me just just give it a new line as well. All right, so once we have that, I'm going to start this server at port 1337, because why the hell not, right? So it's listening on port 1337, and now we could just verify that if I just do localhost 1337, we get hello world, right? All right, now this is basic. The curl request was basic. Let's do a netcat. So netcat localhost 1337 and hit enter. All right, so at this point, what's happening is that netcat established a TCP connection to this host at this particular port, right? So you see that we get only a single request from that curl request, but no request further because we haven't sent the request yet. So how do we send a request using netcat? That is, we have to write the HTTP request ourselves. So I'm going to write get slash, which is, get slash index.php. So we want the index.php resource, right? And I want it to follow HTTP 1.1 protocol, right? So this is basically how HTTP protocol works, how data is transmitted, how when you type google.com in your browser, this is what your browser sends. Hit enter. Now, once I do that, this particular piece of information is sent to the server, but we need more information. I need to specify a host, that is the host address of the resource I'm looking for. So in this case, it's localhost. So I'm just going to go with host, localhost only. And I could specify more information, but for now, I don't need that. So I'm just going to do an enter again, and it would close the connection. Now you're going to see, once I press enter at this particular point, we got this as our response. Now, our server said this particular thing, right? So this is the information for the browser, and this is the content which is actually displayed on your screens, right? So you see that server says that HTTP 1.1, it's okay. My host is this is the date, and it says that please close this connection. I don't want to keep this connection alive. And then some additional information, which is basically just done by this PHP server itself, right? Now we could just go ahead and send a garbage response, and you're going to see that we get an invalid request here in the PHP server, which is a malformed HTTP request, right? So HTTP works on a very plain text protocol, right? You just need to specify the method you want, method first of all, then the resource you want, then the protocol you want to follow, then some additional information like the host, and basically that's pretty much it, right? And some other headers if you want. Now, coming back to our slides, we're gonna see that we just made a request something like this, which includes the request line, first of all, that is line number 1. Then we have the header one, which is the host header. Then we can have, other headers as well. Then finally, we need an empty line to indicate that, yep, we are done. And let's let server handle our request now. Now for the request line, we know that basically we need the request method first of all. You can see that we have the get method here. So you can have any of the valid request methods which the server support. Request URI is basically the resource you want from the server. Then the HTTP version is basically what version should the client and the server conform to while communicating. And the rest of the stuff is just some headers, right? So I hope this video gave you a little bit of insight in what the HTTP is and how it works and how you can actually communicate it using raw TCP sockets. So just before closing off this video, let me just go ahead and netcat to Google as well and see what happens. So I'm going to say I want get the home page and follow HTTP 1.1, and I'm just going to say host is google.com and hit enter. All right, so you see that we get a nice little response like this. Google says that, hey, it's fine that you're using HTTP 1.1, but we have moved permanently, and this is the new URL where you have to go. Notice this is www, right? And some other information and some HTML as well, which basically just redirects you anyway, right? Welcome to another video in web security, in which we'll be taking a look at an attack known as slow loris attack, which is based on the last video, on the content which we covered in the last video. So if you haven't seen that, make sure you see that. So in the last video, we saw how HTTP protocol works, what it is, and how it actually works. So let's just go ahead and really quickly see once more how HTTP protocol works. So I can use netcat as the utility to actually open raw TCP sockets to any host. Now in this case, I'm using google.com on port 80. So once I do that, what you're gonna see is now I have a raw TCP socket opened, and I can communicate with google.com on port 80 using HTTP protocol. So I'm just gonna say that I want to get the slash, that is the home resource, using the HTTP 1.1 protocol, and I want to say the host is google.com. And once I say that, you're gonna see that Google responds with the following content, that it has been moved to www.google.com. And finally, when you visit this URL, it will actually redirect you to the secure version of it. All right, so once we have this particular thing working, what you could see is that when I write something like this, and I'm basically doing, get slash HTTP slash 1.1, when I hit enter, this particular line right here is actually transferred to the remote server, right? So at this particular point, the google.com host is actually waiting for me to send more data. It's not that when I write everything, all of that is sent at once. No. When I'm writing this line and when I hit enter, that particular data is sent to google.com. So if I write host google.com, hit enter, again, this particular line is being sent and Google is now waiting for more data. So I can have x header 1 as some more data, x header 2 some more data, so on and so forth. And you can see right now Google is still waiting for me to complete my request, right? So once I hit enter again, then Google actually parses whatever I have sent and responds me with a valid response. So slow loris attack is basically based on the following working. So in the normal HTTP request, which is just what we performed right now, I send a request and the server responds, right? In slow loris attack, it's a kind of a distributed denial of service attack. It's not really DDoS. You can actually just DOS using slow loris using a single machine as well. So what this does is that it would open a lot of incomplete HTTP request. By that, what I mean is that I would just keep on, opening sockets, that is, keep on opening TCP connections like this one, and I'll just keep sending some data so that it does not die out. So I have, for example, this is one socket. If I open 100 such sockets and I keep on sending data every, let's say, 3 or 4 seconds, then the remote server would think that my internet connection is slow, but actually what I'm doing is I'm exhausting the limit of the connections at that particular remote server, because I'll be opening a lot of TCP connections and the remote server would be opening a lot of threads. Like if you're using Apache as the web server, then Apache uses threads for handling different connections, so you can exhaust the thread pool of that particular server to bring that server down, right? So for example, let me just go ahead and right here go to my PHP server from the last video. So we have, if you see, we just have a simple PHP server which says hello world. So what I'm going to do is I'm going to start this PHP server at port 1234, right? Now what I do is I just go to localhost, that is my same computer, 1234, get /1.1 host 1, and it works just like fine, right? Now what I'm going to do is I'm going to make use of this script right here, which is a simple script which does exactly what I talked about, like opening a lot of connections at first and then just keeping them alive. And if I'm able to keep them alive and open a lot of connections, then I could bring down the host. So you can see right here, I'm starting from I equal to 0 to the socket options, and I'm adding sockets at every connection. So you can see that I have my options set up like the following. So my host is localhost, my port is 1234. I'm opening 2000 simultaneous connections. I'm not respawning the connections which have died out, right? The rate is basically how much you want to send the packets. That is the interval of your, sending the packets. So I'm sending a TCP packet every 600 milliseconds. That is the rate. Method is the type of request you want to perform. Get is fine, and the path is basically the path of the request, right? So now what happens if I run this index.js, what you're going to see, it starts activating sockets, and right here, if you focus in the area below, you see that our server actually closes it, right? Because the server goes down. Again, let's try this one more time and run the node script again. So you see that around 1000 connections, the PHP server is unable to handle that particular. So how do we know that this is different? Let's see what happens if I actually close the connection. So right here, the part which is responsible for keeping the connection alive is this particular thing, right? So what happens if I just say socket write is a new line, and that's it, right? And now I comment this particular piece of code, which is basically this particular piece, right? So we are not keeping the connection alive now. So what happens if I start the PHP server again and run the same script? You're gonna see that now my PHP server is very well able to handle all the connections, and it does not go down. So you see it still lives, right? We could see that I could still perform a GET request to this particular server and it still responds. But once I try to keep the connections alive, in case of the slow loris attack, you're gonna see, just like we saw, that it basically crashes the remote server, right? So again, there we go, around 1000 connections, we're gonna see our server actually goes down. So this was a simple demonstration of slow loris attack, how it works, and basically how you could use this to exploit servers. And again, just make sure you use this content for educational purposes only. Do not pen test on any other site, because that is not only illegal but would actually get you in real trouble. So measures to actually prevent this is basically rate limiting the connection limit per IP. That is the easiest way I can think of. So you do not really want to allow 1,000 simultaneous connections open from the same IP address, right? Now DDoS handling is something which is very different and should be left to companies like Cloudflare. But for simple practical preventions, just rate limit your IP address for a connection limit, maybe like 50 or 60 connections. Welcome back to another web security video, in which I'll be covering this video titled as DevTools for hackers. Now, a lot of times you would see that DevTools, whether you're using Chrome or Firefox or any other browser, basically just suffices your need a lot of times. That is, a lot of people I know use tools like Burp Suite in order to capture the request, modify them, and send the payloads again, or any other like Postman or something. But if you know about HTML, CSS, JavaScript, if you're coming from a web developer background, something like that, then I think DevTools is very, very comfortable, and it has a lot of tools which actually help you directly, do a lot of stuff which you do with other pen testing HTTP monitoring tools, right? So what I believe you should know as a hacker for DevTools is that pretty much the console part, the sources part, and the network part, and some sort of application part as well. So starting off with the console is basically the place where you can write your custom JavaScript and it will just execute on the behalf of the page, right? So whenever you're doing some sort of JavaScript based testing, or maybe you want to ping an endpoint, you just basically have to do a fetch request, some endpoint. Basically you can just go ahead and write your own custom request, right? Now other fancy editors do provide you with the option of building these requests out of the box, but it's pretty quick to just write it yourself as well if you want to, right? So anyway, console is the scripting part. We would be using it a lot of times, right? Especially when you want to ping the remote endpoints, or you have to do some sort of work with JavaScript itself. Okay, so next thing I want to consider is basically using the sources tabs for not only just hacking, but also for debugging purposes, to see if you can manipulate JavaScript in real time. So what happens is, if you go to, for example, the static JS, and let's say I select this index.min.js file, it's going to open this JavaScript file. I'm going to click on this pretty print to actually, format it nicely. Now, what happens if I want to change some sort of JavaScript execution meanwhile it's executing? Well, it is completely possible. And what I could do is just click on this line number right here, and it will just turn, in a different color. Once it does that, that means that your browser will pause the execution of the page rendering when it encounters this particular line. So let's just go ahead and refresh the page and see how it works. All right, you can see that we get a paused in debugger message right here. And if I pretty print this again, it does it itself. I am paused at this particular line execution. Now I can go back to my console and hit, B. So now, right now, at this moment, I'm executing code not on the behalf of just this page, but actually as if I was writing this code right here at this particular point, right? So we have, for example, let's see, we have B as, some sort of complicated object. I could go ahead and set B as null, right? And I can resume the execution. Once I do that, you're going to see that it crashes the JavaScript code execution at this line, because now I cannot set the inherits property of null, right? So this is something you should know as well if you're working with Chrome DevTools. Now, apart from these breakpoints, you can also make them conditional. So if you just right click on this, you can see that you get remove breakpoint, edit breakpoint, and disable breakpoint. So if I edit this breakpoint, it allows me to enter a condition, which is when the browser would pause this on this breakpoint whenever this condition is true. So for example, I could just say, hacker mode is true. So whenever hacker mode is true, then only it will pause this condition. And right now, if we see window.hacker mode is undefined, that means it's false. So I'll just set it to false and refresh the page. And you're going to see that we still get the execution paused on this because, yeah, hacker mode equal to true because it's a condition, right? Not an assignment. So let's just do it one more time. You're gonna see if I refresh this, now this does not work because, now hacker mode was not true, so it does not pause the execution. So this is how basically your sources would work. You can see all your breakpoints here as well if you want, and basically locate all the files which a particular website is loading from the sidebar, right? Another interesting thing is the networks tab. It is something you're going to use a lot of times. So network tab basically shows you all sorts of network requests a website performs, right? Segregated by their content types as well. So most of the times you'll be either in all tabs or in JS or in XHR, stuff like that. And yeah, I mean, you can just see the status code, what it is returning. Once you click on the network request, it's going to show you the actual HTTP request and response. Not really actual all the times, but in most of the cases, it does show you. So this is the request it sent you. Like this basically is just like what we discussed in the video number, I don't remember exactly, 1 or 2 maybe, in which we discussed how TCP works. So although it is HTTPS, but it is still HTTP, right? So it follows the same protocol over a secure communication. So you get a status code, you get a request method, you get the remote IP address of the website. And you also can see the response header, the kind of headers they send, the cookies if they send anything. And you can also see your request headers from your endpoint. So once you do that, what you want to do in a lot of cases, for example, if I'm, just go ahead and sign in into Gmail. Let's do something. So if I just go ahead and write something like ABCDEFG and just change my password to 12345 and click on next, you're gonna see it attempts me to log in and it shows me a challenge, right? Because it finds my activity suspicious or some sort of thing. But you can see right here, we get the full form request, whatever Gmail is doing. It's doing some serious encrypted stuff. I don't know why they are doing this much, but you get the idea. So if you are on a simpler website, you can actually steal the request the website is making to the endpoint and actually, copy this particular request. So you see that right now we made a post request with the username, password and stuff, and the username password must be here somewhere. I'm not just spending. Yeah, so here we go. So this is the captcha value and the password might be here as well, somewhere encrypted. So anyway, the point is that you can actually just right click on these requests, copy and copy as fetch. So once you do that, what you could do is move to your console, hit Command K or whatever to clear the console and paste this particular request. Now, in a lot of cases, it won't look this fuzzy. It would be much cleaner. But, once you have your request copied right here, you can go ahead and tweak some of the things if you want. For example, this Gmail thing is a really bad example for this. But anyway, yeah, I mean, it's not very good example for a post request. Anyway, let's just bear with me. So I'm just gonna go ahead and get rid of the whole body, and I'm just gonna say, for example, username is admin and password is admin. Right, so we can do stuff like this and hit enter, and you can see that it returns me a 400 error, which is like, this is not allowed, not permitted, whatever it is. Right, and we can see this request again. Now, if you want to copy this as a curl request, you can do that as well. Curl is basically a way to perform network request using terminal. So once you copy this as curl request, it's going to copy this as a curl request, obviously, and you can just go ahead and paste it in terminal. This is extremely useful whenever, for example, if you're performing a network request from the browser, but now you want to perform a network request from a remote server whose only access you have is the terminal. So I use this technique a lot of times while downloading stuff. So I'll start the download from the browser. I'll capture the request, copy it as curl request, go to my remote server and download it there on that particular server. So that is how you can make use of it. Apart from this, for the applications part, you're gonna see a lot of local storage and stuff here. So you can inspect the local storage of the particular website and see what key value pairs it has set. For example, if I just go ahead and set local storage.set item key 1 value 1 and go to the sources tab, the application tabs, I can see that key 1 has a value 1, right? Similarly, local storage, similar to local storage, we have session storage, which you can also see if it is set in a key value pair. Then we have cookies as well. So you can see cookies if you want to, and you can actually modify these values as well, just like you like, admin true, whatever it is, gaining access to Google's main servers just by setting admin true, because why the hell not, right? You can modify the domain this cookie targets, you can modify the path this cookie targets, the expiry date, everything. And the size is obviously determined by the length of your value, right? So you cannot obviously directly modify this. So yeah, application tabs is good for taking a look at cookies and stuff. I actually use a different extension altogether called edit this cookie. The reason for this is because it allows me to quickly export and import the whole JSON payloads of the cookies as a whole. So I can just, export the cookies directly and, import the cookies directly as well using this particular extension. So it's pretty cool, right? And yeah, that's pretty much it. You would learn this stuff as you practice and try out the stuff with different websites, see how you can become more comfortable with it, because this is something you won't learn in a day. You have to eventually get used to make use of developer tools a lot of times in order to become comfortable with this stuff. So just consider this tutorial as a way of just letting yourself know that these things exist in a browser development environment and use them to your benefits. Next time you want to perform an HTTP request in the background, which is a post request, fire up your DevTools, go to console, or maybe go to network tabs, copy that particular request, paste it in console, and modify it and send it. Right? So that's how it should work. What encoding, encryption, and hashing is, and what are the differences between them. So let's get into it. All right, so starting off with encoding. Encoding is basically a technique for transforming the data into another format. Now, a lot of times what you want to do is you want to transmit a data from one point to another, but in case of, let's say, in case of web development and stuff involving HTTP, let's say you want to transmit an image using URL. Now, this might sound funny, but how would you actually do that? Now, you have an image in the format of PNG or JPEG, which is a binary file, and you want to transmit that particular image using a URL. So how would you do that? Well, you would encode that particular binary into a different format, which uses ASCII characters and basically characters which are allowed in the URL to pass that, right? Now, encoding a lot of times is just used for transmitting data for usability and stuff. And the best example for that is base64 encoding. Now, if we see base64 encoding, just like I talked about the URL, you see we have an image right here, which is this graftar URL. You can see that this is this little image right here. And if I run this code snippet, we're going to see that we get a base64 URL of this particular image, right? Now, if I go ahead and copy this, you're going to see that we have this image, this data section as the base64 equivalent of that particular image. You can see these are all characters, but they actually represent an actual image, right? So base64 uses 64 URL safe characters only, which allows you to transmit this particular thing over the wire using HTTP, using URLs, right? So just to prove my point, I'm just going to go ahead and copy this whole thing right here. And I'm going to just go ahead and paste it right here in the URL, right? So you see the URL says data image PNG, which is in base64 format, and this particular whole thing, right? Now, if you want to just verify the stuff, what you could do is just take this URL right here, and I can say const image is this thing. And now I could just say B to A image, that is my image, right? So you can see, not really B to A to B image, right? So you can see that this is a raw image, a raw PNG image with all the hex values and stuff, which actually construct this image right here. But we have safely encoded it into a different format, and we can decode it back using A to B. That is a publicly available scheme. So encoding basically just means transmitting, transforming data into a different format for various reasons of transmitting, or maybe usability, or any other thing, right? So you can see that you have MP4 files, you have WMV files. So these are different encodings, right? Which are publicly available. You know how you can transform MP4 to WMV. So these are all encodings. Coming to encryption. Encryption is basically for keeping your data safe, right? So encryption allows you to keep your data safe. Data is safe as in it actually makes the information which you're transmitting as garbage. So once you do that, what you have done is that anyone who's seeing that particular information in between of the transmission does not see anything valuable, right? Encryption uses a key. Now there are different ways of encryption. There's a symmetric way and there's an asymmetric way. We'll come to that later on as we proceed with the series. But with encoding, you saw that we did not use any key whatsoever. So it was a specific written format. With encryption, it's basically a matter of uniqueness to that particular encryption, so that we have to make use of a key. And the examples for encryption is AES and RSA, right? So once you connect to a site which is like a secure site, like HTTPS site, what you're basically doing is you are encrypting your traffic. You're not encoding your traffic. You're encrypting your traffic. So anyone who's seeing your network traffic does not know what you're transmitting, right? So that uses a particular key and a particular algorithm for that particular encryption. And two of examples of encryption are AES and RSA, right? More on this stuff later on as we proceed. Then it comes hashing. Now hashing is basically a way of validating the integrity of a file or a resource or a string or whatever it is, right? In a lot of cases, that's what it is used for. Now, what does that mean is that hashing is very useful when you just want to verify, but you don't want to store a particular piece of information. For example, let's say you are creating a website where you store the usernames and passwords of people. Now, you would never want to actually store the passwords of people in plain text, because that is never going to be the case when you need to see the password or you need the user to see his or her password, right? User just types the password, sends it to the server. You're gonna hash that particular password. That is, you're gonna turn that particular password into a garbage value, which is always predictable, right? And the special feature of hashing is that it's one way. So you cannot get that particular password back from that particular hash. Think of it more like as an output to a very complicated algorithm which produces garbage for the same input, same garbage for the same input, or a linked garbage for the same input. So you can always relate that, yes, if I put in ABCD1234 in this machine, I will get this particular garbage out. And you can never go back from that particular garbage to the original value, right? Now there are of course rainbow tables and ways to crack hashing algorithms like MD5 and SHA1, but we'll come to that later on. The purpose of hashing is to create a one-way function which encrypts, not really encrypts, but which basically turns the piece of code of information into something which is non-decryptable, right? Some of the examples of hashing are SHA1, SHA256, SHA512, MD5. There are a lot of hashing algorithms, and we'll see a lot of them over the course of this playlist. In this one, we'll be taking a look at some defense mechanisms for the web security part. So this is basically the part one of, I guess, 2 videos for defense mechanisms. Let's see how many we can create. And in this one, we'll be discussing user access and stuff. So the basic principles for defense mechanisms is basically you have to prevent users from having unauthorized access for your web application. You have to handle user input to prevent unknown behavior on your server or on other users' profiles or any sort of page which is exposed to them. And you have to monitor the application itself for, for performing analysis or seeing if there's any sort of attack going on, or if there's any sort of mischievous activity done by any sort of user. So starting with user access in this one, basically it consists of authentication. So in authentication, you have to make sure the user is who the user claims he or she is, right? You have to treat all the users anonymous by default. Anonymous is basically the lowest level of trust you can have on any user. So your application by default should treat all the users as anonymous. That is, you should have lowest level of trust or no trust at all on any user, whether it's any user submission or any user input, any user action, whatever it is, right? For improving authentication control, you can also have multi-staged login. That is maybe OTP on email address, that is one-time password on email address, two-factor authentication, stuff like that. So that could be implemented to improve authentication. Now, there are some fundamental flaws with authentication as well, which are very commonly found on the web. So for example, the first one I can think of is guessing usernames with error messages and different sort of messages, which is like one of the most common flaw, I would say, in authentication mechanisms. And I'll just show you one example as well real quick after this. There are login bypasses as well for authentication systems, which is a whole another deal, but it still happens, right? The most famous, not really the most famous one, I wouldn't say that, but the one which came to my mind immediately when I wrote this point was the Tenda router login bypass, which basically allowed you as any user who's connected to some sort of Wi-Fi to bypass the router login authentication and modify the router configuration basically just by immediately as an anonymous user itself. So you can just Google the Tenda router login bypass thing. Just Google this phrase and you'll just know how this worked, right? But for now, I want to show you this guessing usernames with error messages thing. So yeah, I won't get into how or why this works, but I have the site. It's kind of like a service I used to have before, but what these guys do is, for example, if I enter anything, you're gonna see that, well, they say roll number or password provided is incorrect, please try again. But what happens if I enter correct roll number and password is obviously incorrect? And if I hit login, you see that while they were coding this interface, they were actually checking for roll number and password, and somewhere on their backend, they have the implementation. If the roll number is correct and password is wrong, return this message. If both are wrong, then return the other message. And the other message had this n as small. Now, the things like these, small things like these in web security can actually help you discover a lot of possible resources, a lot of paths, a lot of routes which should not be open, to people, right? So once I have discovered this flaw, I can basically now validate any sort of user on this site. So if I maybe just go ahead and try to log in with the admin, you see that we get a small n. That means there's no user admin whatsoever. So I won't waste my time brute forcing any sort of password for admin user at least, right? So administrator. So I can basically just, pull out a dictionary of common administrator accounts and, just filter it down to ones which exist on the site, and so on and so forth. So get into that stuff, right? So this is basically one of the flaws. So moving forward, the next thing we have is session management. With authentication comes session management. So session management allows your server to differentiate one user from other users, right? So your server would be receiving multiple requests a second. Some are for static resources, some are for some are for actual data retrieval, some are for authentication, so on and so forth. So it allows you to differentiate one user from other. And how does it do that? It basically creates a session for every particular user using a token. Now this token is sent to the client, which makes use of this token and sends it back to server on every request, or on at least on the request in which he or she wants to authenticate him or herself. and that could be done by HTTP cookies or basic auth. And finally, a couple of flaws with session management could be weak or predictable authentication tokens. That is, your tokens are basically just combination of username and password and MD5'd over that. So that's a weak combination of token. And maybe if you're storing session data on client side unencrypted, that could be accessed by anyone who's browsing the site. First case. Secondly, anyone maybe who found a cross-site scripting attack, some sort of vulnerability, is able to extract data from local storage. So that is also one of the flaws with session management, which is pretty common. So yeah, that's pretty much it for this video. If you liked it, don't forget to subscribe. Thank you for watching, and I'll see you then in the next one real quick. If you're still watching this video, make sure you comment down in the comment section, I watched this video till the end. Also, if you're not part of Codedamm's Discord community, you're missing out a lot on events which we organize on a weekly basis to code. You already know the drill. Make sure you like the video, subscribe to the channel if you haven't already, and thank you so much for watching.